In this video, we're going to talk about how to solve systems of equations by substitution. However, if you notice, this is part 2. If you haven't yet, go ahead and watch part 1, and that will make this make a little more sense. We're only going to do one example in this video, but it is a little bit of a more involved example, and we'll be writing the steps as we go. So in this example, I'm going to put the example here, and then on the right side, I'm going to list the steps that I'm following. Just in case you're looking back at this, it might make the example make a little bit more sense. Okay, so our system of equations is negative 3x plus 2y equals 7, and x plus 3y equals negative 6. Okay, so step 1. I'm going to need to isolate a variable in one of the equations. All right, so isolating the variable, what I mean by that is get one of the equations to be x equals blank. That means x is isolated. Or y equals whatever. That means y is isolated. Right, if you go to part 1, you'll notice that all of those examples already have that, already have a variable isolated. But in this problem, right, we don't have that yet. However, I notice this second equation here, x looks fairly easy to isolate because all I have to do is get this 3y over to the other side. So let's go ahead and do that using our mathematical tools. All right, in order to move that over, I actually have to subtract 3y from both sides. And I'm left with, well, 3y minus 3y is 0. All right, and I get x equals negative 6 minus 3y. Because they're not like terms, so I can't combine them. All right, so that is step 1 complete. Step 2. Next up is the actual substitution step. So we're going to substitute that what we just solved for in the equation that we haven't used yet. So in this case, I'm going to scroll up to see that. The equation I have not used yet is negative 3x plus 2y equals 7. And what I know is that x equals negative 6 minus 3y. So I'm taking this x and replacing it with negative 6 minus 3y. And after I've done that, I'm going to go ahead and solve. Right, I can solve now because if you notice in this green equation, there's only one variable, right? In the entire equation, I only have y. In both of my original equations, I have x and y. All right, so having one variable, I can go ahead and solve. So I get 18 plus 9y plus 2y equals 7. I got that by distributing. Next up, I'm going to combine my like terms. Subtract 18 from both sides. 11y equals negative 11. Divide by 11, and I get y equals negative 1. All right, step 2 is done, but we're not done with this problem yet. Step 3. I need to solve for the remaining unknown variable. In this case, that is x. So in this problem, if we scroll back up to the original, x plus 3y equals negative 6. You can use either one, it doesn't matter. But I also know that y is negative 1, so I'm going to replace y in this problem with negative 1, another kind of substitution step. And I get x minus 3 equals negative 6. Add 3, and now x is no longer unknown. We know that x is negative 3. Finally, last step, and I put it because students always forget it. Step 4, write your solution as an ordered pair. Right, so the answer is not negative 3, it's not negative 1. The solution to this system of equations is negative 3, negative 1. And there we go.